Our project team worked with the Mid-Atlantic Mother's Milk Bank. Mother's Milk Bank is a Pittsburgh nonprofit, and their primary operations consist of screening new donors and processing the breast milk that they receive. Processing the milk consists of thawing breast milk deposits by mom, pooling multiple moms' milks together, bottling the milk, and pasteurizing the pooled milk. After this, the milk goes to hospital and ICUs where infants need the nutrients and immunological contents that are present only in breast milk. Recently, the milk bank purchased the Mirus Human Milk Analyzer that has the capabilities of determining macronutrient content such as calories, fat, and protein. Mother's Milk Bank currently provides randomly pooled donor breast milk to prescribing physicians. Because milk is currently pooled in the absence of nutritional information, the prescribing physicians assume that milk is average and fortify accordingly. Mother's Milk Bank desires the ability to start pooling milk based on the macronutrient content in each donor deposit, which will in turn allow prescribing physicians to more accurately fortify the milk. In order to achieve the objective of producing NICU and outpatient pools that are within certain specifications, a threefold approach focused on the creation of a target pooling model, a donor database, and a standard operating procedure. Target pooling model. One of the most important steps in processing donor milk is the pooling step, as pooling balances the macronutrient contents and enhances the immunological profile. Mother's Milk Bank desired a tool that allowed them to create pools with specific calorie and protein levels, so our team pursued an integer program that allowed for the creation of high-calorie, NICU, and outpatient pools of milk. The main difference between these pools is their caloric specification. Each pool had additional constraints that were determined by Milk Bank Association restrictions, as well as requests or desires from the milk bank. Some of these constraints included limiting the number of donors per pool, limiting the SSRI user percentage per pool, and restricting volumes to be in increments of 100 milliliters. The team chose to use an Excel open source solver to create the integer program, as it is free to use and does not require extensive technical knowledge for the end user. To assess the success of our model, pools that the milk bank created prior to the implementation of our model were compared to pools that were created with our model. To compare the difference in the pooling methods, the calorie and protein levels of 1 month's worth of data was studied. The average energy of NICU pools created using target pooling is closer to 20 kilocalories per ounce, and the standard deviation is greatly reduced in NICU pools using target pooling. All 58 of the pools lie within the desired energy region using target pooling, while only 10 pools out of 52 lie within the same range using random pooling. Additionally, the average protein of NICU pools created using target pooling is increased and the standard deviation is reduced in NICU pools using target pooling. Donor database. The team chose to pursue the creation of a donor database to allow the milk bank to make thawing decisions with knowledge of historical donor macronutrient information. To create the donor database, donor macronutrient data was compiled into an Excel pivot table that included basic caloric statistics such as donor minimum, maximum, and a weighted average. The donor database is shown here. This example shows that without knowledge of the macronutrient content, it is likely that the milk bank would have pulled many low-calorie deposits for that day, as they all have the soonest expiration date. The addition of these values obtained through continued macronutrient analysis should help mitigate the risk of thawing a group of deposits with energy content above or below the desired energy content range. Initially, the milk bank's original process was not documented. To mitigate the loss of information, a standard operating procedure was created that integrates the target pooling model and the donor database into the milk bank's operations. Process maps and time studies of the original process were completed to better understand the limitations and the opportunities of the system. Measured improvement. Key changes between random pooling and target pooling is shown by the drastic reduction in variability in the energy content of pools and the drastic increase in the pool volume generated within the desired range for NICU infants. Processing time did increase by implementing this process. However, the benefits of target pooling for premature infants is significant, as shown by the results. Recommendations and implementation plan. The milk bank has already began to use the new standard operating procedure. The milk bank began using target pooling when the project team was on site, which allowed the team to receive feedback and make minor adjustments. With the help of the pilot run and the standard operating procedures, the milk bank technicians will be able to successfully target pool donor breast milk using the Mirus Human Milk Analyzer going forward.